In this video, I'm going to give you more examples of domains with multivariable functions. So suppose you have a function looking like this. Get a 3D graph plotter, plot it, it will give you this surface. So when it comes to domain, try and look at this and find out when this thing will break down. Well, this thing here will break down when this thing equals 0. So we demand that x squared plus x squared minus y squared cannot be 0. That's what we need to demand. We need to demand that this thing can never be 0. So what does this mean? Well, add y squared to both sides. That will then give you this. So just demand that that y squared cannot be the same as x squared. So what that means is this: if you have y squared cannot be equal to x squared, what it means is this: if you look at the so normally when you picture a 3D function, in your mind you will picture 3 axes. So it's like this: x, y, and z. But we are just looking at the domain. So let's just picture it like this: x and y. And this thing here is actually describing this thing here. It's actually describing y equals x and y equals negative x. Because even if you select something like this, let's say this is negative 2 and negative 2. So when you put this into here and put this into here, well, if you square negative 2, they will both be the same. But you demand that these two cannot be the same. So really, this thing here is describing this cross. So your domain is actually, there are lots of ways to describe a domain depending on who teaches you. But here's another way: x and y such that x squared cannot be the same as y squared. So if you look at this, this is your x-axis. This is your x-axis. This is your y-axis. Oops. This is your y-axis. And your z-axis is straight up. But if you look carefully, you can actually see the cross here. There's something weird happening at this cross, and that's our restriction. Oops, that's our restriction. This cross here is really near enough this cross here. If you plot this into Google, it will sketch this surface, and then you have the ability to rotate this. You have the ability to rotate it. You can actually look down on this, and then you can see there's something weird happening at this cross. Okay, well, next one. So let's look at the domain for this function. So for you to look at the domain for this function, when would this thing break down? Well, we need to demand, well, if you look at the natural log graph, it looks like this. We need to demand this to be greater than 0. It cannot be on the negative side. So we need to demand that this needs to be greater than 0, strictly greater. So what does that mean? It means we'll add x to both sides. So it means that y must be bigger than x. So what does that mean? So in your mind, draw the domain plane, and then draw y. In your mind, picture this: y equals x. So that will then give you this, and then y equals y bigger than x simply means all this region here. Okay, so that's the first part. But then we need to consider this as well. When will this thing break down? This thing will break down when the denominator equals precisely 0. So this thing cannot be 0, and also we need to demand that this, well, square root graph looks like this. It cannot be negative. So we need to demand that this thing cannot be negative. So we need to demand this. We need to demand that this thing be greater than 0. It cannot be equal, greater or equal to, because if this thing here is 0, then when you square root 0, then the denominator will be 0. So it cannot be 0. So wait there. So we need to make this demand. we need to make this demand. So what does this mean? Well, let's rearrange it. So rearranging this, add y to both sides. So that will then give us this. What does this mean? Well, let me just imagine it like this. Y equals x plus 1. Let me just imagine it like this. Well, this thing here is saying this. Hang on. Draw your domain. Well, let's just draw this line. Y equals x plus 1. So that would be this bit here. Intercept of 1, a gradient of 1. So that's this thing here. But we need to demand that this thing be greater than y. So let's select an easy point. Let's select the origin to test it. So put this into here. So this thing here would be 0. Put this thing into here. This thing here would be 0. 0 plus 1, that would be 1. So 1 is greater than 0. So this region here is good. So what this is saying is this. Hang on. What this is saying is this. Oops. What this is saying is this. This is 1 here. All this region here is good. So this is in our domain. But if you look at this bit here, earlier we said that we demand that this thing here be this thing here gives us this region here. So now we need the intersection of the two, which means it's this region here. It's just badly explained. I hope you can follow that. So our domain is actually this. Our domain is actually this. This is 1 here. So our domain x, y is just this region here. Okay. So domain x, y such that x is greater than y is greater than x. So that's y greater than x is all this here. And then this thing here, and y is less than x plus 1. So that's all this region here. Well, for both of them to be and, it means you're talking about this region here. So the domain for this function is really this strip here. And then if you look carefully, there is a strip. There is a strip here. If you look carefully, there is a strip, because this is your x-axis, this is your y-axis. Well, this strip here, actually, if you rotate it and look down on it, you can actually pretty much see the strip. Okay, so that's your domain. This is our domain here.